Built in the 1970s, the Voyager probes were designed for a 5-year mission. Just recently, NASA began reducing their power consumption to extend their final years. These aging spacecraft are still transmitting data from the edge of the solar system, farther than any spacecraft we've ever sent. But how do you build something that lasts longer than civilizations themselves? This is the story of how they got there and why they might outlast everything we've ever built. Before Voyager, NASA launched two other deep space explorers, Pioneer 10 and Pioneer 11. Pioneer 10 was the first spacecraft to travel through the asteroid belt and the first to reach Jupiter, launching in 1972. Pioneer 11 followed a year later, adding the first flyby of Saturn to its resume. Both missions were huge achievements, and they were also the first to carry messages to possible extraterrestrial life. Each Pioneer probe had a plaque bolted to the spacecraft, an illustration of a man and woman, a diagram of our solar system, and a map showing Earth's position in the galaxy. They were our first postcards to the stars. In terms of endurance, Voyager surpassed Pioneer in both distance and longevity. Pioneer 10 lost contact in 2003. Voyager 1, launched 5 years later, is still communicating in 2025. Now the farthest object humans have ever sent into space. So, we've talked about the incredible distances Voyager and Pioneer have reached, but the real question is, how did they get there? The answer lies in a fascinating technique known as gravity assist, or the slingshot effect. Imagine you're trying to cross a large lake. If you're paddling, progress can feel slow, and it takes a lot of effort to cover a great distance. But what if, instead of paddling the whole way, you could use the current of a fast-moving river to help carry you? By positioning yourself just right, the river's momentum speeds you up. Then, once you're ready to leave the river, you guide yourself out into another calm lake, but with much more speed than you started with. The river gave you that boost, and now you're ready to keep going with the extra momentum. Spacecraft like Voyager use the gravity of planets to achieve the same effect. As Voyager swings around a planet like Jupiter, it picks up speed, much like you gain momentum from the river's current. Once it exits the planet's gravity, it continues to travel at a faster pace, ready for the next stage of its journey. These spacecraft were assembled using the best tech the late 70s could offer, and is nothing short of remarkable. Their onboard computers each has about 68 kilobytes of memory. That is less than a single email. Their data recorders, magnetic tape. Think of it as a cosmic cassette deck. Their communication systems, a 23-watt radio, about the same as a fridge light, beaming data back across over 50 billion miles of space. Their power source, RTGs, or radioisotope thermoelectric generators, tiny nuclear batteries built for space. They lose about 4 watts a year, but that slow, reliable output is exactly what kept Voyager running for nearly 50 years, even out where sunlight can't reach. People sometimes say, how could we go to the moon with 1960s tech? But here's the counterpoint. Voyager, launched in the 1970s, was using technology similar to Apollo, and is still alive and working in deep space today. Tech doesn't need to be flashy to be powerful, it just needs to be smart and reliable. If the Pioneers carried postcards, the Voyagers carried something even more ambitious. The Golden Record, a 12-inch gold-plated copper disc, essentially a time capsule from Earth. It holds 160 images, 19 minutes of music, greetings in 55 languages, the sound of a kiss, a heartbeat, and even a baby crying. The idea wasn't just scientific, it was poetic. If extraterrestrial life ever finds these probes, the Golden Records say this is who we were. There is also something clever hidden in the design. Electroplated onto the record's aluminium cover is a tiny dot of uranium-238, a pure radioactive material. Over billions of years, it decays at a known rate. By measuring it, a distant civilization could calculate when Voyager was launched. It's a nuclear clock, quietly ticking long after everything else goes dark. The record is protected inside an aluminium case, along with a stylus and instructions for how to play it, like a vinyl album from another world. It's one of the most human things we've ever launched, a mix of curiosity, hope, and cosmic imagination. In March 2025, NASA confirmed that Voyager 2 had shut down one of its last science instruments, the Low Energy Charge Particle Detector, to save power. This followed Voyager 1, which turned off its cosmic ray subsystem a few weeks earlier. The reason? After nearly 48 years in space, their power source is fading. They've lost about 40% of their energy since launch, with just enough left to keep a few instruments alive. Even with less power, they're doing what no spacecraft has ever done, operating in true interstellar space, billions of miles from Earth. And in 1990, Voyager 1 captured a final look back, a family portrait of the solar system. Earth appeared as a tiny speck, a pale blue dot. That single photograph, though low in resolution, became one of the most iconic images in exploration. A reminder of how small we are in the vastness of the universe. Even though NASA is slowly powering them down, the Voyager probes are still transmitting science. But we're nearing the end. By around 2030, both Voyagers are expected to lose the last of their power. Communications will cease. They will go silent, but they won't stop traveling. Voyager 1 is moving at over 38,000 miles per hour, and Voyager 2 isn't far behind. They left the heliosphere, the magnetic bubble around our solar system, and are flying through the interstellar medium. In 40,000 years, Voyager 1 will pass within 1.6 light-years of another star. By then, our cities will be gone, our languages forgotten. Maybe even the sun itself will have burned out, and yet those golden records will still be intact. A message from a little blue planet that once looked up and wondered.